Dr. Manoj sir join meeting. एक मिनट હું એને પૂછી જ લઉં. Good evening, sir.
Good evening.
So Manoj sir already joined. So our first speaker is Dr. Manoj Kumar, Director of Innovation. Dr. Kumar is working as a Director Innovation and is part of ST's Global Innovation Office, reporting to ST's Chief Innovation Officer, CIO. He is functionally reporting to Managing Director ST Microelectronics India. He is supporting ST's initiative of scouting for external innovations worldwide. In this mission, he works with various ST organizations and key stakeholders to collaborate with R&D houses, startups, and university with the mission to connect these to relevant business R&D division of ST. He is driving ST India in-house incubation program and STEAM initiative. He is managing the system applications and integration lab of the SRA with global mission to bullet and support reference designs, software and system solution in area of connectivity, EV, charging station, energy efficiency, and IoT as well. He is executive council member of the India Electronics and Semiconductor Association, IESA, and board member of Electronics Sector Skill Council of India, ESSCI. He is based out of Greater Noida, India, has been with ST Microelectronics since 1999. And he has all over 30-year experience. And I would like to invite him as a first session speaker. Please, sir, share your knowledge about IoT and present your session.
Thank you, Dr. Ravish. I am wondering if I am ahead of time because time given by you is 6:30. It's not a problem to me. I'm just wondering if some people would be joining at 6:30, hoping that it will start at 6:30.
Okay, no problem.
No, I mean, it's up to you. I'm ready because
Well,
I have.
You can start.
All right.
They will join me.
Okay, perfect. Then let me share my screen and I would ask. Please confirm me that you are able to see my screen.
Yes, it's visible, sir.
And it is in full screen mode also?
Yes, full screen.
Perfect. Thank you. So good evening. Thank you, management of SN Patel Institute of Technology and Research College Institute. Thank you particularly Dr. Ravish, who was following me, and also I had some engagements in between, but he continued to pursue, and here I am. So thank you again. I'm very pleased and honored to speak to this AICTE, you call it ATAL FDP. And I was talking to Dr. Ravish, wondering about what should be the topic. And I think I found out that maybe looking at the agenda, there are deep topics that several eminent speakers are covering. So I thought I would kind of give an overview from the industry perspective. And of course, I will speak in general about industry, but all my examples would be coming from ST microelectronics. And here, of course, you can imagine that I can give the examples where I have a direct role also. So that should be kind of normal. I would say I'm not here to promote ST microelectronics in any manner. Of course, you can imagine me. You can consider me as a representative of an industry which is semiconductor industry, and of course, this is the industry that is driving all the innovations in IoT in any case. So, with that disclaimer, I would also make a comment that in my slide, you would see that there are some references to the sources from internet, but also there are some references to certain technical reports. I have tried to minimize those references, yet those references are there, and wherever I had to refer, I have given two reference. So again, I would say that there is a credit given to those agencies where I have used some specific data. With those disclaimers, let me forward, and also I would make a comment that during my presentation, if you think that there is a need for me to emphasize on certain part more than something else, please feel free to write in the chat. I would be looking at the chat in few intervals, and I would try to, let's say, modify the direction of my presentation accordingly. What I have prepared for today, I will give you a brief introduction about my company so that you understand where I am coming from. I felt before jumping into IoT itself, it was important to speak about megatrends. What are megatrends and how IoT is discovered to be a megatrend, not by my company or our kind of companies, but by the bodies like United Nations, which are pretty, let's say, impartial. They don't have any specific attention or attraction to the semiconductor business, yet they identify IoT as a megatrend. I would give you some examples of IoT applications. And intent here is I'm speaking to the faculty of Indian eminent institutes. And as an industry representative, I have some feeling that we are working in certain manner in industry, but also even if I graduated some 30 years ago, I have a fair idea of what happens in our institutes. I have been in constant touch with various institutes, even ever since I have passed out. So I would give you some hints as to how you can be more effective in producing, let's say, industry ready talent. I would be spending some time giving you some examples. Then I would go to the next part, which will be that as an IoT innovators, there is a plethora of information, boards, tools available from semiconductor companies. I would speak about that, taking, of course, example in particular of ST. I would also speak about some educational platforms that we have created, and then if you would wish to create an IoT lab, how you could get started. Second part of my presentation would be to highlight the importance of multidisciplinary approach, working in the ecosystem, and working with and for the standardization, where I have taken some representative examples. The idea again is to highlight that we can succeed in isolation, but we can better succeed when we go together. And I would give you some examples and my thoughts on that. In the final part, I would be speaking about what is coming up next from us. And this would mean not only the devices, the solutions, but also some new technologies. In the end, as Professor Ravish told in the beginning, I am also a executive council member of IESA, which is India Semiconductor Association. I would represent a chart coming from them, and I would highlight to you the importance of system design and essentially the importance of building IoT systems. That is what I have created for you today. If you think it will be meaningful, you may write something in the chat, and if you think I should highlight one particular section more than the others, also write that in the chat. All right. So moving straight away to ST Microelectronics. ST Microelectronics is one of the largest semiconductor companies. Okay, and we pride in saying that we are one of the few IDMs. What is IDM? Is integrated device manufacturer, which means there are semiconductor companies which are fabless. There are some companies like TSMC that you know, which are only fab, but there are other set of companies which have their own design, their own manufacturing. We belong to this category, and this category is what is called as IDM. We have 14 manufacturing sites of our own, and then these are the details. What is most important detail over here is that we have close to 10,000 R&D engineers out of 50,000, and out of these 10,000, more than 1,000 are based here in India. These are our R&D and manufacturing locations. So you can see most concentration is in Europe. So we are a Franco-Italian company, but we do have manufacturing in Singapore, in Malaysia area. And of course, we have R&D here in India, as you can see. So this pink dot is indicating R&D and then sales. So in India, we are primarily an R&D center. Where would you find us? We do a lot of work in the semiconductor area. And in the end, when the semiconductor goes into the car, it goes into the factory or into the building, or devices like Alexa, for example, what you see is the make of the end product, and you do not see the semiconductor content, which is making it really working, that you do not see. And it's not a complaint. It is just to say that semiconductor devices are forming all of that we see in daily life, yet you would see a brand name that appears. So for example, there could be a car from, let's say, Audi, Mercedes, and so on. But let's say most of the electronics in that comes from semiconductor companies like us. So these are our major focus areas: driving smart industry, industry for 4.0, 5.0, smart homes, smart cities, and then of course connected devices. If you look at it, one common thing in all of this is that these are all IoT devices. Looking at the August gathering here, I don't need to define what IoT is. You know everything about IoT, that you are talking of the connected devices, to say the least. Then of course we go into the next one, which is like power management. It comes like computing, it like connectivity, security, and so on. But at the minimum, we are talking of the connected devices. And all of these devices, systems, are actually connected systems today. What is our strategy? Each company is in the business of making money, so to speak. We also say we are in the business of making products, which is truth. But someone says that you are in the business of making money first. So when you have to do this, you have to align with what are the mega trends in the world. Mega trends, I will speak little later. Today, I am referring to long-term enablers within ST. Long-term enablers for us are smart mobility, power and energy, cloud connected, and autonomous things. This last part is certainly entirely IoT, but power and energy is also an integral part of IoT, because you need IoT devices that can sustain for a long time. Talking of one particular area out of the three on the previous chart, that is the cloud connected autonomous things. What it means is that we are talking of more than 20 billion IoT connected devices per year by 2025. And these would be growing at an aggregate rate of, let's say, more than 30%. Now we are talking of not just IoT, but just one particular category, which is edge AI. We will speak a little bit of intelligent devices at the edge little later. The point to be noted over here is that there is a big installed base for the IoT devices. And then one particular segment within that is the security services for IoT that is increasing. And then edge AI is something that is going to see huge growth, and this growth will continue till now. Again, wherever there would be references, you would see some such reference like this is coming from ABI research. Last slide on the company. It's important to mention that I mentioned that we are one of the few IDMs, but we are also one company which is not only having its manufacturing, but we are having manufacturing in MEMS, call it analog, CMOS, call it digital, and then RF, and then specific memories. For example, we have phase change memory. So it will come a little later, which is very unique in the world, and very few companies have that capability. We are there into the silicon carbide. Silicon carbide is the wide bandgap material, as is gallium nitride. So when I say that we are into silicon carbide, I am speaking that we design as well as we manufacture. Everything that you see over here, we design those products in those technologies for those technologies, and we also have our own fabs to produce them and eventually sell in the market. Packaging is very, very important aspect, and of course, we are into all of that. So this was a brief introduction about ST Microelectronics. If it is okay with all, I don't know how I can see the chat now, but if it is okay, please say something, or maybe someone can comment if the speed is okay, or I should go fast, slow. Anyone can say anything in the chat. I am trying to look at the chat on other monitor. I don't see anything, which could mean it's okay. Okay, let's look at what are the mega trends. So, first of all, a mega trend is a trend which comes into the folklore, whether we are part of it or not. That means you can't stop it if you want. And there are some ways which were identified by these people, Kuhn and Margelos. What they say is that one way to identify a mega trend is to look at where the research is happening, where the research analysts are speaking about, and what is the level of political attention that is being given to that particular subject. Also, you can have political attention, but are there investors who are also looking into that? And then is media paying sufficient attention? And then if there are some social advocacy groups which are talking about that particular trend, if you think all of that are happening at the same time, concurrently, we are perhaps talking about a mega trend. That is how these gentlemen defined that this is how you can identify a mega trend. What is important to us is to look at the mega trends that were identified by United Nations. United Nations have identified several mega trends. The mega trends of importance to our discussion today are urbanization, demographic trends, and then of course, new technologies that are emerging. So these are the mega trends that have been identified by United Nations. How these are important to us, we will see in a while. But let's look at another independent body which speaks about, again, there is a trends wheel, which means that which are the mega trends, and then how they arrived at the mega trend is also written. For example, in the middle circle, you would see what is immediately known is happening now, then is somewhat known, that means in a somewhat distant future, and then the further one is really in a distant future. They also classify that if you look at the major axes that are over there, they identify demographics and urbanization is going to be a mega trend. Human augmentation, that means augmentation of our experience by all means, Industry 5.0, future of mobility, personalization of healthcare, connected world, and so on. These are going to be the mega trends. And I was looking at the agenda of the FDP. Most of these are anyway connected. So somehow I think the FDP content are pretty relevant to the mega trends also. So these are not only mega trends relevant to IoT, but in general, the mega trends. That is very important. So I consider that the FDP has been well designed. Last chart on the megatrends. If you look at the electronics and system megatrends, again, I remind everyone, maybe someone joined a little late, we are talking of the megatrends in the context of IoT. And here, this particular list is saying, coming from Yole Intelligence, you know that Yole Intelligence is a company which gives a lot of information about the semiconductor, about the electronics field. For the electronics, they have identified these megatrends. Let's read them. Edge computing, 5G technologies, IoT as a subclass itself, AI, Industry 4.0, AR, VR, biometrics, then vehicle mobility, more efficient data monitoring, more sensors. To me, even if IoT is one of these, from my perspective, all of them are actually pointing to IoT. Do you agree? Someone could say yes or no. I have no way to understand if you are writing anything, or I don't know if chat is disabled. But so far, I haven't been able to see anything if you have written anything in the chat. Do you agree that or everything that you see on this is electronics and system, but it's really IoT? Okay, there is no way to take feedback, and I don't know how to ask your feedback because I don't see anything in the chat. Maybe when I will stop little while, I will stop sharing, then I will try to look into the chat. For now, let me move on. So a comment over here, the electronics and system mega trends actually point to very big way to the IoT itself. Now, let's look at one particular aspect, that what are the social mega trends behind IoT? Urbanization. And what is meant by urbanization? Concentration of more people into less land. And that would mean high rises. That would mean additional requirement of lifts. That would mean requirement of efficient motors. That would mean that the precise indication of the floors, just talking of the lift and so on. But that would also mean that if there is a locality which is having, let's say, 500 houses in the same building, maybe you will not have those many people or helpers who could come to the different houses and do the household chores. If that would be the case, you would go into the another aspect, how I can automate. So comes the washing machine, comes the robots, comes the cleaning, and so on. So this is the reason that urbanization is resulting into a mega trend which we call as IoT. What happens to the demographics? In India, we are a country, fortunate enough still, where most of us are staying with our parents. This is not the reality in the rest of the world. The developed world is having more and more population, which is living longer, number one, because there is a better health care, but also living alone. And also, they are living longer and many times even without work. These people need to be supported. So imagine that there is a person who needs some attention, but the attention is not available from the people. Hence comes the machines, hence comes the robot, hence comes the situation that you could have a wheelchair that could move from one portion to the other portion and also do some commands. For example, if there is an elderly person who is not able to move his let's say hand, can there be a system that he could move on a chair to a distance, and then maybe the object could be as simple as maybe sugar. If the sugar could be, let's say, brought down, but how would it happen? All of this would happen because of the electronics, but the demand is rising because there are now more people who are in the old age and who are also alone. If it was old age and with the family, situation was little different, as is situation in India or most of part of India. But in many other countries, people are living well beyond 90 years of the age, and maybe last 10 to 15 years of their life, they are alone, maybe together with wife or husband, and in many cases, just alone. That means only one person is left. That's creating new kind of demand. And similarly, the environment, there is a global warming. Then we need to have a situation that there are, let's say, less pollution. You know that in Delhi, from tomorrow again, there is a GRAP 3. That means you can't drive even BS4 diesel vehicles. But these kind of requirements are coming more and more on the environment. For example, electric vehicles or electric vehicles with a longer range. So all these trends are actually driving the IoT. So this is important for us to appreciate that when we talk of IoT or FDP or even otherwise, we are talking of a field that has been identified to be the key field by the agencies like United Nations, by independent agencies, by agencies like your group, and this is resulting into many organizations going behind IoT. Of course, my organization, as you have seen, we have three pillars: smart mobility, power and energy, and cloud connected autonomous things. To me, the last category is essentially IoT. It is also interesting, again, this is coming from ABI research, to look at what all were the enablers for IoT. I mean, it's also interesting and historic for the electronics engineer, and I believe most of you could be electronics, electrical / computer engineers. But it's interesting to see that it was 1876 when telephony or telegraph was, let's say, invented. Then we went on to the fact that there is a telephony, but okay, there could be need in the military. There could be military radar, or there could be barcodes, and so on. And this is an interesting field to have a breath here and to understand what is written over here is cross-industry experimentation. And today, any innovation that is happening, the innovation is having more impact when it is cross-industry. That means you design, you take the strength of one industry, take the strength of the other industry, combine these two, and then the combined strength is much, much higher. I will illustrate this later. Hence, I am inviting your attention to cross-industry experimentation. Then, of course, beyond that, it has been network, wired, wireless, okay, IPv4, IPv6, 4G, 5G, 6G, and so on. And then, of course, we are living in the era of the 5G. But if you look at the right side, what we are talking about, the IoT verticals and deployment, and this is going to happen now and it will continue beyond 2028. What we are talking about? We are talking about smart homes, smart health, connected transportation, manufacturing, connected energy, and connected agriculture. Again, I am reminded to say that all these fields are somehow covered in your FDP. So FDP is very well designed. Okay, there is another important slide to understand what is driving the IoT. So let's look at what is a typical system that we call as the IoT system. We said before that an IoT system is where you have some kind of connectivity, you have computing, you have some security, and you have some sensors, and you have some data to transmit. If you look at what is driving the IoT more and more, it is the digitization. That means digitization of everything. So you start from the cloud. At the cloud, there is a data for everything that you can imagine, every kind of industry, every kind of city, and so on. What happens when you join the IoT or you connect the IoT devices to the cloud? So there can be, let's say, interchange of the information between the device and the cloud, but also device anywhere, located anywhere. What happens when we move a little further? Here, you can imagine that the situation is that IoT device is kind of sensor device, but without any intelligence. What it means is there is a sensor which senses, maybe there is some ADC. It simply gives out the output of the ADC and sends to the cloud. The processing happens at the cloud. Next, there can be some intelligence at the edge. That means I don't need to send all the raw data to the cloud for the processing. If that is the case, that is what we call as edge. That means something could happen at the edge also. And this would mean that there are very rudimentary basic decisions that are made at the edge, but still most of the computing or most of the decisioning is happening at the cloud only. What happens when we come to the AI? AI can do many jobs autonomously and independently right at the edge. And also there is a concept that you can have some kind of learning that is happening at the cloud, but really the implementation happens at the edge. You understand all of those aspects. But all these devices and then going next up to the digital twin is actually what is driving enormously the growth of the IoT devices themselves, growth, usage, and so on. You understand that digital twin is a concept where you don't need to have, let's say, an accident really happening. You can even simulate the accident, giving the actual signals that would come before the accident and eventually then prevent the accident. So that is the power of the digital twins, where you have the real physical signals who can really simulate and actually emulate the real environment also. If the environment is that of, let's say, an accident, you could create one, and you could create an accident by yourself and see what would be the impact of the accident, and also what really resulted into the accident. And then if you know what really resulted into the accident, you already know how to prevent it. So that's the power of, let's say, digitization and IoT and data, AI at the edge. These are, let's say, fueling the IoT growth. Again, to take care of all those mega trends and what I spoke before, I was speaking of the IoT devices at the edge. I was speaking of the ecosystem. I was speaking of everything that was happening in the devices and at the edge. It's not a job and game of one company to do everything. In fact, what we need is a big collaboration across the industries. And when across the industry, many players are working, that means they are actually trying to address the same mega trend. So if imagine that you have the IoT device coming from a company like mine. So you have a IoT device which does everything and can send to the cloud. But what happens if cloud is very, very expensive? Imagine, look at that. Or what happens if the telecom services are very, very expensive? It won't work. So each industry need to work along with each other to really lower the barriers on their own side. If there is a cloud industry, they need to lower the barrier. Then you see that there are some companies which offer you free credits. Okay, you take $10,000 worth of cloud services from provider A, provider B, and so on. They are in a way lowering the barriers. Or our kind of industry, which develops products to lower the barriers for development, and then telecom industry. I mean, this is just an example based on the previous slide. This is how, when there is a mega trend, many industries come together, many nations come together, many governments come together to really address that mega trend. Again, enough of the mega trend and IoT. Now we can go to really the next part. Let's look at some of the example applications of creating IoT products. And in this section, I want to draw your attention that I would be speaking to you with the intention that you promote the right usage of electronics in the student community. That's my intention here. I start with a wristband example. You see, there is a real photograph, and it really looks very, very simple, pretty simple. I think you would agree. These are the kind of pedometers that you have seen, you have used, but we never probably bothered that there is some attention that is required even to create these simple designs. That's why I start with this one. Let's look at the board layout. So in a pedometer, you would have an MCU for sure. You would have an accelerometer, let's say MEMS accelerometer. Then you would have a way that there is a battery. So battery should be somehow charged so that there is a battery charger. Then you need to communicate. Let's say in this case, the communication could be simple. Let's take the case of NFC communication. NFC is the near field communication that you use in the payments also. Looks fairly simple. Let's move on. When we make its assembly, first of all, there is a form factor. If there is a board that is given and we have to simply demonstrate a pedometer function, it's pretty easy. I'm sure many of you have done it, and not only you, many of your students would have done such an activity using multiple boards. What I'm trying to highlight here is when you have to work in a form factor, that means the wristband has to really fit on wrist, not just to show that there is a board you move like this and then it can count the steps, etc. That part is relatively easy because there are many examples which are existing for free and available for free. But when you make a form factor board, there is something very interesting that happens. So imagine that you have this wristband, this is the top side, this is the bottom side, and on the bottom side, somehow you have to attach this battery also. But what is the battery? You have to agree, you have to understand the usage need and what is the milliampere hour that you need, how much recharging should happen, and also when it is put into the casing, are you able to enclose it or not? I was saying that not only we have to have these elements, but also you need to communicate. And when you communicate, the question comes, where do you put the antenna? The antenna has to be obviously on the upper side, but the moment you go into the antenna design, it starts to become an interesting design, interesting packaging situation. The concept of showing this wristband to you is that something that appears simple as this, looks like given, has several aspects of designing before it comes to us. This is not a very professional design because it was made really maybe some 10 years ago just for an event. And the idea was that if there is a user at some event, give him this wristband and then he goes on everywhere, and wherever there was this NFC stuff available, he will go to that booth and then it will be counted at how many places this person has gone. It's somewhat similar to the attendance that was being talked about for you in the FDP before. So to design such a system, it takes that much of effort. And many a times when we consider that these systems are available, we consider them to be available in very simple terms. I want to highlight, please design by yourself, and more importantly, make your students design something that fits into the final shape at least. You would realize that many a times creating the system is not so much of electronics or computer job. It's also mechanical, it's also aesthetics, it's also behavioral, it is also psychological. And those elements, when you combine together, then you make a product nation. I will have a slide in the end that what we are lacking as a country is to have this kind of imagination where we don't think of the products as a merely assembly of some electronics component, merely something that is an app like this, and say that I have created this system, but make a system that looks like product, that behaves like product, that works like a product. That's my primary purpose of showing this simple example to you. Let's move on. From smart me, that is speedometer, let's go to the smart lock. Little complex. What are the use cases of the smart lock? As you understand, it could be used in hotels where you could provide app-based access to the room. Also, if there is someone in the room or not, or it can be in houses, or it can be for the care of the senior people, because to know when some people or the known person has entered into the house, and also if someone is, let's say, coming out or going, I mean, be a situation that there is an elderly person who forgets when it happens. Then for you, it can be very meaningful to understand if he has gone in or gone out when you are not at your home. Smart lock can do it. And it can be helpful to the disabled people. Let's move on. The main challenges for the smart lock in this case are security and the battery life, and how these are addressed. First of all, let's look at various kind of connectivities. So here you can imagine, so this you can imagine as the wristband that I was showing in the previous case. So with the NFC, somehow you have authentication that it can be opened, but also you can give some code to the Bluetooth. You can enable certain mobiles that with a certain code you are able to operate the smart lock. And then at the cloud, it could be connected through, let's say, Wi-Fi 4G, that is your phone is connected, but it can have a direct connection through little long range connectivity called LoRa, Sigfox, NB IoT, etc. On the other hand, this can be your inside the home where it is connected to some PLE Wi-Fi gateway, can be sub gigahertz, and this gateway eventually can have this in-home display or your laptop, but then eventually it is also connected to the cloud. So this is the overall scenario of the smart lock. To make it happen, I mean, imagine that when pedometer or this dumb stuff in the previous example was interestingly complex, what would be the complexity in this case? Let's look at some security requirements. Obviously, access control has to be only to the authorized persons because we are talking of the smart lock. It has to be available. I mean, it's not that it is so very secure that, I mean, it is secure, but no one can operate it. You know that there is this famous CIA, that is confidentiality, integrity, and availability. All of those have to be respected. Business and brand protection. Imagine that maybe you are having a Godrej smart lock and it doesn't work the way it should. What happens to the brand? They took some smart devices from some company and now there is a question on the brand itself. And finally, it should guarantee the privacy as well. So the solution is the standard security and cryptographic primitives, encryption, integrity, and authentication. Compare it with the previous case, the complexity has grown. Again, there are threats that no one should be able to, let's say, counterfeit it, but then there are security services in between, and then there are benefits. The key point that I want to drive is that let's look at some of the most common elements into a system that we are calling smart lock. So look at the power management, human machine interface, sensing, proximity, accelerometer, MEMS, vibration, temperature, ambient light sensor. All of these sensors are very, very important, but also there should be camera. And this camera can also have the face recognition. So you look at this aspect that a simple device like, or perhaps it's not so simple, a smart lock is having so many components, and these components have to work with each other to give you the required functionality that we discovered in the previous pages. Then look at the wireless connectivity. It is no longer just NFC. There are, let's say, UWB or Wi-Fi modem, Bluetooth, NB-IoT, and so on. But when you are talking of this kind of smart lock, there is also a key that is operated. That means now you are going into the world of motors, because the motors can only, let's say, move those locks such that it locks or unlocks when it has to, let's say, move back. One simple stuff is having so much to do then besides these protections. You look at the fingertip authentication, or there is a bell that is happening at the door. It has to give out a readout loud if the person is allowed or not. So this is how the complexity starts to. Looking at the control unit is something interesting. So you have the microcontroller, you have the security, you have the protection, and some kind of memory, some kind of resets and supervisors. All of those start to become very, very interesting on the one hand, but also very, very complex systems on the other. And keep in mind what I said in the previous example of a wristband, form factor is what is important. If you had the luxury of using one board for each one of them, it was possible in the first place. Okay, then we go to the next one. That was the hardware, but then there is a firmware. Then there has to be, of course, some board support packages, drivers, some middleware that takes care of it, and then finally application, which is kind of the user behavior in that. And look at the right side, you have the connectivity, you have the sensors. These are the details in this particular design that was done here in our team, that which kind of MCU, imaging, MEMS connectivity was used. More than anything else, I want to draw your attention to this particular name, which is ex nucleo. And I will be discussing a little later. And ex nucleo from us is something which is like capability to enhance in one particular field. In this case, this ex nucleo is providing you the function of the NFC card reader. This will come little later. And I am speaking only about this on purpose because this purpose would be highlighted little later. So in the end, how does the system look? So, just to remind you, I was referring to this kind of structure before, where if you follow my cursor and little deep blue or deep green board, that is the ex nucleo, but the white one is what we call as nucleo. So nucleo is the one that has the main microcontroller, and the other one is which is having a specific function or functionality. In this case, for example, you can see it's a Bluetooth Low Energy. plus also some MEMS or let's say other connectivity. So this is a real lock, and here you can see there are form factor boards that have been made, and this was done at ST, but on the left side is what was done by the end customer. And here it is important to note and understand that end customers have much more capability than us as system designers. And the reason to say this is that electronics or application or software doesn't make a system sell by itself. In the end, you need someone who understands a little bit more than that, probably not as deep here as we may know, but this depth is not sufficient because this could work as a smart lock. Who would buy this, we can say, nice looking or ugly looking product as a smart lock? You need something that looks like one, that has actuators and so on. And this is done by these OEMs, ODMs, and so on. So there is a lot of system design expertise that exists in those. And probably that is the expertise that we should focus in the country, and you should focus with your respective students. Having these boards connected is the first step, and usually I'm aware that that becomes the last step also, not only for our BTech level but sometimes even at the MTech level, and that is something that we need to collectively think how it can be changed. All right, then the app. Again, summarizing where we are, we talked of a simple pedometer, then we went to the complex situation where we created another system which is like a smart lock. I was also having an example of a smart meter that I have skipped. I am simply jumping into the smart home, remembering that we are now talking of a system called it smart home, which is comprising of several such systems. First of all, pedometer was a small subsystem into the smart lock. Now, smart lock is a simple or small one of the components of the smart home. There are many more things that happen. So this is how we can go on visualizing that pedometer was simple, NFC reader and an NFC connector, smart lock. You enter into the home. Then there are, let's say, in home display, there is a smart meter. There are smart fans. There are smart lights. There is a comfort. There is a EC. There are heat cost allocators depending on the country that you are in, and so on. And then there is a security. There is a surveillance. Everything put together. And then there is electric vehicle chargers. You are able to, let's say, charge the electric vehicle from the electricity, but you are also able to charge or reverse charge your home in case there is not electricity from the car itself. All of that is actually number one electronics, but number two also IoT, because everything stays at the cloud thanks to the ubiquitous connectivity that we are having now. Again, now I will go a little fast, but looking at this, what are our needs at the smart homes and buildings? Presence detection, for example, people counting, indoor tracking, and so on. Okay, all of that. Smart appliances, you have the smart motors, you have room Jumbas, you have every kind of, let's say, surveillance systems and so on. Customer user manager is how you interact with that. Also, now there is a very important category that is emerging, which is the structural health monitoring. I think there could be some session in your FDP, but anyway, this is one of the very important and niche area for the IoT applications. And then real-time monitoring of the environment and so on. Again, if you look at the energy management aspect of the smart home, so there is a EV charger, but it can also reverse feed your home. If you look from the AMR or AMI perspective, it's called the automatic metering infrastructure and so on. So there is a meter that is to your home, and then you can have your solar power, you can have inverter, you can have your washing machines, your chargers, and then you can have several type of possible connectivity protocols depending on the continent or country you are in. There can be KNX, PLC, etc. if you are more in Europe, and RF hybrid mesh network if you are in India, America, and so on. Again, talking of this smart home, it's not in isolation. You can make as you want, but you have to understand what is happening in MBUS, what is happening in LoRa. You have to be part of the alliances which kind of govern, because alliances are very, very important. Standards are very, very important. Governments would decide, okay, I want to adopt meters and more. The moment you say, I am into meters and more, all the requirements of the meters of the country would be governed in certain manner. The moment you say I am into G3 PLC, it will be governed in another manner. Hence, it's important to understand the different standards, be part of them, and develop accordingly. Let's look at the presence and occupancy detection. For example, I was speaking about you could have the presence detection, and time permitting, I will speak about a new sensor from ST, which we call as the TMOS sensor. And of course, there is a alarm, PIR replacement, user interface, intercom. So this is a typical smart home scenario where we have lighting, we have people, we have different functions, whether people are present or not. Accordingly, the lighting can be different. At this stage, I go to the next. I have a really urgent need to understand if you are understanding me well or not. And I'm trying to see if there are any messages. Either there is some problem that I don't see any message, but some messages would really help me to understand if I am well understood or not. So there is no way that I can find out. If someone can write somehow, that will be great. Okay, how ST is addressing the developer needs. So how I started my presentation, I started with the mega trends. Then I went to the aspect as to how IoT is one of the big mega trends identified by several organizations. I gave you some examples of building the IoT applications. I could have gone the reverse way, and the reverse way was to talk about the boards, the tools, etc., etc. I am going in the reverse manner, and that is on purpose. The purpose is to first locate where are the IoT applications, and then come back to the devices and boards. You have seen whether it is wristband, whether it is meter, whether it is smart lock. The devices are coming in many form factors. Look at the lenses also. This is also one of the IoT device. Form factor is very different. Requirements of the system design are very different. What we say is that no matter what is the size of the IoT device, function of the IoT device, some of the basic needs for them are really common. And those are processing. That means we are talking of microcontroller, microprocessor, security, sensing and actuator. There has to be some kind of sensor. And in case if there is a let's say other kind of actuation like haptic or others, there is actuation. Connectivity is one of the fundamental part to qualify to be a device to be called an IoT device or not. Condition and monitoring and protection, motor control, as you saw in the case of smart lock, for example, power and energy management. So no matter if you are talking of the smart thing like pedometer or smart home, like I said, the smart lock or smart industry, where of course you can have different kind of PLC controls and so on. So the requirement of processing, requirement of security, requirement of sensor, requirement of connectivity could be different, but somehow the needs are common. And this is one very big aspect to understand. If the needs are common, probably we can address those needs with some common methodology, and that is what I will describe now. So these are the essentials of IoT, as we have seen already. Acquiring the data, processing the data, and how you process is your own decision. And which data is acquired is also dependent on your requirement. What is the security, connectivity, and then of course there can be applications specific standard products. As an example, you may have a device which is monitoring your health, and then of course this can become one of the components of the, let's say, application specific product. What we offer to the innovators is we offer the basic hardware building blocks, we offer pre-integrated software solutions, and we offer development and prototyping tools. Let's look at them. You would recall I was highlighting in the context of smart lock structure like this. This is what we call as X nucleo, and the one that looks whitish is the nucleo. So if you look on the left side, we have this offering, what we call as the development board. And then on top of that, we have what we call as the expansion boards or X nucleos. For the main development board, we have the software Also for the corresponding board, we have the software. Imagine that when you have, maybe this is the computer board, and there are these function packs, and this could be maybe one of them is MEMS, the other one is maybe connectivity with Wi-Fi or maybe NB-IoT and so on. So these could be several boards. The way it is working is that you would have a IDE, integrated development environment, which can talk to your board depending on which is the part number. And then if you integrate another board, there is anyway a corresponding software available which can be integrated and then compiled together. And then if you have one board plus one, you would have the software that will correspond to that functionality. It is not that you have to necessarily download the software that is available from us. You can write by yourselves. All it means is that there is a getting started stuff that is already given to you, made available to you. And when there are several such boards, because each board would have a unique function, one board could have a function of, let's say, the motor control, and then other one could have a function of connectivity and so on. When many of these are combined and these are required to be used together in a certain application, we reach into the definition what is called as function pack. And this is an interesting concept to understand. And also, I want to make a comment here that this is not applicable only to ST microelectronics. This is applicable to several other semiconductor companies as well. This is how the standard, they may have their own different names, different ways of calling, but the IoT world is today pretty much driven like this. I want to highlight and give you an aspect of what is this function pack. So I would like to share another site with you. Let me see how I can share. So if I go here, I hope my screen is still visible. And if I say I am reading as function packs, the function packs from ST Microelectronics. So if you go here, you can see that there is a lot of stuff that comes directly from GitHub. Okay, there are several function packs that are available. So again, if you just go to baby function packs, all the function packs, the very first result, here you would see that there are several products that are available. You can see there is a cloud connectivity, network security, sensing, this particular function pack that is there. No matter which function pack you are talking about, there will be product selector. And here you can see which products are, let's say, so if you FP is function pack, AI would mean AI, and then this would mean presence detection, for example. So you have function pack, which is including of, let's say, AI and presence detection. So if you look at this software, so this is a combination of which all boards would be there. So there would be a particular we should go into the other one now. Okay, so there is a particular board for which it would be available. I showed you how to search for the function pack. Imagine that you are searching for a function pack that is available for, we had this function pack for presence detection. So there would be any information that, okay, maybe this is a U5 microcontroller board or nucleo board. And then there is a particular part number, again, X nucleo for the presence detection. If you put them together, and then if you download this function pack, you would have a directly ready to run system that would be able to detect the presence and also count the number of people. If that is the functionality of this particular device, then there would be documentation. So you can go on searching exactly like this. I come back to my narrative again. What we are providing is what we call as STM32 ODE. STM32 is our flagship microcontroller. And later on, you would see that it's most widely used MCU in the world today for development, but also in terms of the real usage, real sale also. So you have this kind of boards, then you have prototype boards depending on the function. And there are now more than 45 such boards. So you can, let's say, design using the board that you have. There would be an example that is given for one particular microcontroller and the combination, but there is also a guide to say that if you have to put into another microcontroller, how to do that. And by the way, to understand these function packs, to understand this function, you don't need to buy any of the boards. These are anyway available directly, even without asking your name, with the full source code. So that is the kind of what is the topic? The topic here is how ST is working for the IoT. Okay, next one. All the software needed to start the application coding from day one is available, and this is professional software. Earlier, I was talking about such kind of wearable devices. Even when you make a software or an application using the boards that are readily available, the software you can write in its final form. And once you put this software into this kind of form factor board, you would know that this software would work as it is. And this is the biggest advantage that we provide to the IoT developers. Of course, this is then further detailed that what you need is to understand which kind of sensors are required for your IoT applications, which are the building blocks. And if you understand the building blocks, you would have everything from day one. Of course, if you know how to make use of the tools, you can really prototype these things very, very fast, and very, very fast would also mean in the matter of days. And here comes the caveat, because you can do and your students can do something in the matter of days, we make a mistake to assume that IoT or electronics in general can be done or can be understood in the matter of days. And this is a big mistake that we are making as institutions, but as also as a country. And this is one single reason that we need to address together with our students, with our stakeholders, that we must make the form factor boards into the final products, even when they look as simple as the first example, that was the pedometer. Of course, you don't need always to have multiple boards. Many of the functions can be combined into the single board. So this is our IoT board. Here you have all function of several Nucleo boards, Nucleo plus X Nucleo boards into one corresponding software. There are situations that maybe you would like to have your own board, own system, but what you need is only the connectivity. But you would like to have a module that you can directly solder onto your PCB. Then there are solutions like this. This one is called sensor type. To summarize, we provide a complete ecosystem to the IoT developers. As I said, these are the fundamental needs of the IoT system. You need boards, you need stackable boards. Sometimes you would need form factor boards also. No matter what, you have this kind of development ecosystem which allows you to develop, which allows you to generate code, which allows you to debug code, which allows you to stop, to run as you like. And then what is important is that you are not bound to the IDE that is provided by us. In fact, there are several IDEs, be it from ARM, Kyle, or IAR, or there is a free one from ST, which is called GCC. But anytime we release a board, we release into all the variants of the IDEs. That is the fundamental requirement, otherwise we don't release. Then, of course, finally, you see that independent of how big you are alone, you need to work with the outside community, because many times the community would have much better ideas than you have. So there are communities, and we depend a lot on you for creating the educational platforms. I will share some that have been created mostly in the US universities later. So today, as a semiconductor company, we lower the barriers for the developers. We provide ready-to-go ecosystem. This is what we said. Device prototyping is good. Making the form factor board is not so easy. And final product is pretty much tough. And despite the final product going to the market is much more tough. And this part is what I call as electronic system design. And I have also made a note over here that this slide will be reused when we will come after the break. At this stage, I have no way to understand if there are questions. Now I will unshare my screen to see if there are any questions, and then I will try to answer. In the meantime, a break of 2 minutes starts now. Okay, so I am back. I could see some of your comments. Time remaining is 0 minutes. So thank you for your comments. Finally, during the break, I was able to see. I hope my screen is again visible. Professor Ravish, could you confirm? I hope my screen is visible.
Yes, yes, yes.
Okay, thank you. Thank you. All right. So what did I cover until now, or what was our objective in the beginning? I said these are our proposed discussion topics, mega trends, examples. We have covered until this. We said ready to go ecosystem for IoT innovators. We covered this. Maybe I come to educational platforms little later. Let me go to next slide, and we have something interesting over here. I want to highlight now a few things. One of them is multidisciplinary approach. I highlighted something in the IoT roadmap, and then how ST is addressing IoT movement, and then I will come to the educational platforms. If I look at my time, I have 35 minutes, so it's a little challenge. Please continue to write the questions in the chat, because now I am able to see the chat when I stop. I would like to answer your questions looking at the chat in the end. Now, if you allow me, if you permit me, let me jump to this session, which is multidisciplinary approach. And the reason to select this is to highlight that creating an IoT system and claiming I have done it is not difficult anymore. I gave you the idea. Today, for as less as some $20, you can buy one board. For as less as $10, you can buy another board. Combining 2, 3 such boards, it amounts to something like $50. $50 is less than 5,000 rupees in any case. Any of the student can spend this much of time, is already spending maybe on the movies, maybe on the petrol. So that is the kind of cost we are talking about, frankly. And it's not a difficulty for any institute to afford this kind of stuff. And then you have the free software that is available from us, available from many other vendors. So to say that, okay, I have this smart home system, I have this smart lock, because it is having bulky 10 boards put together, is easy today, because honestly, other than finding the right sources, nothing was done. And I would recommend that anytime you have such projects, please do nudge your students to say, other than stacking the boards, is there something that you have really done? You can play in the software here and there, change the file names and put some comments here and there. That's not a great job that we should expect from the students. We should really nudge them to go a little deeper and do something meaningful. Here I come to the another aspect. Now it is not for the student, it's for you. I want to start with this example that is fairly simple. There is a audio in this video. You may not be able to hear the audio. And even if you hear, unless you know some Italian or French, you will not understand. But there are subtitles and those are in English. Just watch it. Okay. So this was a smart chair using NFC, using voice commands, using motor control, using indoor navigation. It's able to find the lift. It's able to go to another floor. It's able to go to the coffee. It's able to fetch the coffee also once the chair has reached close to the coffee. So you can imagine where all it can be applicable. If I give you a challenge that makes such a chair, I'm sure many of you would be able to do it. But this is true for many others that you see in this chart. We can make it alone as ST, but so is possible for Amazon if they want. So is possible for Otis if they want. But you look at, I'm just referring to the known names. Amazon, you know why Amazon. Otis is the elevator company, but also there is a coffee. Moshini is the let's say coffee maker. Then there is a university. There is a city club. Torino City Lab is like a fab lab, and so on. And then Politecnico di Torino. This is like a polytechnic in Turin, which is a technical university, like let's say GTU if you want. All these people come together for such a seemingly simple, it's not simple frankly, but when we look at the system in its finality, it looks simple. I want you to know one thing: anything that appears simple is simple because there were intelligent minds which have the capability to hide the complexity to make it appear simple. That's why it is simple. More simple an aspect, more engineering has gone into it. But I am highlighting the other aspect. Look at the number of partners. And this is something that we need to do in India also. This is very, very important that even when we understand we can do everything by ourselves, look at the partners, look at the relevant partners. This is the key message that I want to give here. Another project, this was a Europe-wide project. Now I was talking of few companies coming together in one area. At the European level, there is a project. Of course, this is coming at the EU level. But when it comes to the EU level, you look at the application. First of all, it was for elderly application. System interfaces, etc., would be defined by our kind of companies. But then you need to work with the medical manufacturers. You need to work with the healthcare professionals. You need to work with the research institutes like Fraunhofer. You need to work with other companies, sometimes even competitors. And then you work with the people who know their field better. That means when you're designing a healthcare system, just to say that I know electronics, I know some apps, I can design, it's very easy. it can earn us some BTech and MTech, but only that much. It will never sell a system. Hence, working with the partners is very, very important. Third system, relatively simple. Imagine that somehow the ecosystem is of smart bees. Smart bees, you understand the honey bees and all. I will be going fast on these pages on purpose. The point is that there are now few faculty professors involved from here and there. What is the purpose? A purpose would be to understand how the ecosystem works, how the CSR works, and someone would understand how the honeybees work. And when you have such people who can give you these inputs, we as electronics engineers would understand much better how to translate those inputs. But it's important to work with them, to understand their language, and break this barrier of how a healthcare professional, a medical professional, or even sometimes even a psychology professional would talk to an electronics engineer. When we are able to convert that or converge into that, that is where the real innovation happens. Innovation at the edge is much easier. Sometimes we become so involved into our own deep field that electronics engineering department will not talk to electrical. Electrical will not talk to mechanical. Mechanical will not talk to computer. And the result is what we have. Again, we need to start this partnership at our own institutes level, and then one institute with another institute, and then one university with another university, one state with another state, and then one nation with another nation. When we have that approach, we would be succeeding much better. Again, this is what it means. There are parameters that you control. You understand when the queen bee is coming, what happens, how do you identify all of that. And for that, if you look at it, the system that we are using from our side is actually fairly simple. What is not so simple is to understand the behavior of the bees. So instead of, let's say, starting from class 1 again to understand the behavior of bees, work with the professionals who already understand. Work with the universities who are, let's say, leading into that domain, and we focus on our work. And this is again, finally to say, it was one of the anyway standard boards from ST Microelectronics that was used, but that was doing this purpose when we were working with other partners. Okay, final example. This is a little bit futuristic and not strictly IoT also, but I want to give you the sense that how it is important to work with the standard and standardization companies. So there is something called Global Battery Alliance. Some of you could be aware. Those who are not, you can search as I am speaking. So Global Battery Alliance is something that is aiming at to understand that anytime you have a battery, let's say vehicle battery, you should have a kind of barcode on that, 2D, 3D, whatever, and you have your phone, you point it to that, and you would understand the entire history of the battery. Is it first time, second time, third time? Who manufactured it, which country it transited through, and so on. All these people have come together. You see, why they come together? There is a reason for public and international organizations to come together. NGOs, there is a reason. Technology and service providers, there is a reason. Industry and business, there is a reason. You remember what I was saying with respect to the IoT and then this big data movement, that we need many, many industries coming together to address one mega trend. This is another mega trend if you want. How do you take care of the electronics disposal? How do you take care of the battery? How do you take care of the aspect that it is not employing any child labor? So these are the solutions that are happening. And this is not yet commercially available, by the way. This is something that is in the making. I'm giving you the aspect that when you make something big, you have to work in this big ecosystem. And many times with your competitors. And this concept would be called kind of battery minerals. I described what all it would have, but it will ensure the traceability using blockchain and everything. You see now blockchain is coming into picture. The first life, second life, state of charge, state of health, everything of the battery is coming into picture just with this. And this is one of the new big applications. So if you look at the battery life stakeholders view, who are the stakeholders from the supply chain, there would be battery makers, car makers. From the material point of view, who are they? Okay. But then what happens when this is, let's say, manufactured? It goes to the owners. There is an insurance that is involved. But maybe you sell it after some time, there is a resale. So second owner who becomes the first owner and so on. And then what happens with respect to the car life? What happens with respect to the battery life? All these aspects are being defined today. It's important to understand. If you search many products, there won't be many. There could be some, but there won't be many because this is a kind of initiative under definition. And you look at the number of partners that have come. So battery passport will manage a quality level so that a buyer can trust that their battery is really eco-friendly rather than trusting someone who may not be so trustable. In the end, if you look at the last view, this is the devices. This is where we come from. And here you can see that we are not alone. There are competitors over here. Then comes to the module, then comes to the system, then comes to the OEM. And in the previous chain, we were considering OEM just as one entity. So this is how this entire ecosystem is now having about 200 companies, which are, let's say, part of this battery passport. The purpose of giving you these 2, 3, 4 examples. I started with a wheelchair. It can go to the second one. There were universities involved. There were city governments involved. I went to Serene IoT, which is European level initiative. Then I went to a local ecosystem concept that we work with the people who have complementary skills or multidisciplinary skills, the example of these. And finally, the battery passport. The intention with that was to say that really we have to go in a multidisciplinary way to really succeed beyond a point. Making a prototype is easy. As I said, is easy. Advanced topics, let me skip for now. I want to go to another category, that how ST is addressing and leading the IoT movement is what I want to highlight now. Okay, changing the gears now. I hope you are with me. I'm still in my office, so would be you or at your homes, but be with me. It's important section now. In the beginning, I said we are one of the few IDMs, integrated device manufacturers. We have seen Moore's law. We have seen that there are limitations to Moore's law. But then there came the thought that why not have something what we call as more than Moore. And more recently, there is a big talk of heterogeneous integration. And when you talk of the more than Moore, you have the technologies. And now you recall I was showing you one technology chart from ST. There were MEMS, there were RF, there were BiCMOS, there were BCD. So digital technologies, analog technologies, RF technologies. Now you see mix of all of that. When you look at the mix of all of that, these are the applications that you are able to address, be it smart home, smart industry, smart city. I want to inform you that, of course, we are talking of making an application based on the devices that are somehow available. But if you become a big company, you made a system, IoT system or otherwise, and it is selling in millions. Very soon, you would hit a competitor who would say, okay, I am having a similar system, but I am having a better, power performance or power consumption for my device, which is doing the same job. Suddenly, you would find that the customers would switch loyalties. But where does this power performance come from? It comes from the technologies, not only from the systems that we talked about until now. There are underlying technologies. Imagine that you have a technology that is working at 5 volt, 3.3 volt, 1.6 volt, or 0.67 volt. So if the band gap or the switching is only this much, the switching losses are also that much less. And the system is efficient because what is input power versus output power and the losses subtracted in between. If lesser are the losses, more efficient is the system. And this efficiency comes from the technologies, and we are the IDMs who design and also provide the technologies. As an example of new product, of course, based on certain technology, there is this TMOS sensor. What is TMOS sensor? This is again an infrared sensor that measures the amount of infrared emitted from the objects. Objects can be human beings. If you look on the left side, of course, there is a IR wavelength that is given and so on. Distinctive characteristics of this is that it's very, very low power consumption and compact size. We are talking of IoT. One of the IoT application is also people counting. And people counting can be done by the famous PIR sensors. What happens is that they are able to detect the people when they are moving for sure. But when they are not moving, you don't know if people are inside or not. This is not the situation with the TMOS presence sensor. And earlier I was showing you one product with respect to smart lock. It was about presence detection. Or even our function pack that I showed you, it was about presence detection, PDET. It is that detection. That means we created a sensor called TMOS sensor, which will give you the presence of the people inside a room even when they are not moving. To create this, of course, it needs to understand the technologies. Otherwise, you could count at the door with the conventional PIR and you were happy. When situation is stable, you don't know. Then what happens? If there is a lighting control, automatic lighting, that happens in a room, depending on if people are inside or not, you would see that in some situations, maybe some bathrooms at airports, if there are, let's say, automatic light, if you are stationary for some time, the light goes off. Not with TMOS sensor. This is how technology makes our experience better or augment our experience. This is just to say that how new devices would create new arenas for the IoT applications. Okay, this is a, of course, to say there is a ASIC and then this is more than more or integration. There is a special kind of packaging. So it's not only the device principle, how you package, that is also equally important. All right. Occupancy detection with TMOS sensor, I think I already explained that it will give you understanding of the room being occupied even when the people are not moving because it's the IR based and then it can sense the heat. Target applications, you can imagine home automation, smart lighting, smart IoT home appliances, because then it can sense where are the people to which direction and so on. Jump gear. I talked about the new devices. For the IoT, it is also important that we continue to have leading edge in the MCUs, in the microcontrollers. ST is having this STM32 and also a few more microcontrollers, but just restricting ourselves to STM32, we are having more than 1,000 variants of this. What does it mean? Depending on the memory, depending on the speed, depending on the pin, depending on the package, you can have, or depending on the peripherals associated, you are having more than 1,000 active parts. So where does it help? If you have to work in an institute, of course, a Nucleo is good. We would have some 15, 20 types of different Nucleos covering various packages. Imagine that you become an entrepreneur, maybe metering is your application, and somehow you are manufacturing something like 50,000 meters per day. For you, each pin is a cost. Each extra memory that is available but you are not using is a cost. You would like to optimize it. When I say we have 1,000 parts, that means we have slotted that there can be 1,000 different applications for each of these parts. That our customers would benefit because they should not be paying more than what is the real minimum that they need to pay for. What is important is that we as ST, we also provide 10-year longevity. That means it's not that we are producing 1,000 parts today. The part that we are producing today, we are giving you a guarantee of 10 years availability. And that's the commitment. And despite that, you would see that we are now having more and more microcontrollers that are being added into our portfolio. For example, you see that, of course, we have in-house technology. Then there is China for China example, but let's not discuss that. Coming to the embedded non-volatile memory, today we have 28 FDSI/18 nanometer, which is ramping and it is in production. What is important is that as per a new report, today we don't talk which is this microcontroller, what is the technology and so on. But in future, because of the aspects that I said before, there is your group which says more than 60% of the MCU shipments in the technologies would be at 40 nanometer and below. Today, you don't ask if your MCU is in 40 nanometer, 65, 90, or even 200. Now, all is fine as long as it is an MCU. But when you have to scale up, you have to look at which is the technology. Because eventually what it means is that there would be an inflection point when these devices would sell in large numbers and economies of the scales would govern their prices to be very, very competitive compared to the even bigger ones. That is what it means. And this would mean that when you are with a organization like ST, which is leading the MCU since now many, many years, you are securing your future. All right, let's go to the next one. Devices themselves are not enough. What you need is also a development environment that is fantastic. And look at the left side. STM32 MCUs are the most familiar in the developer community. This is by Aspen Core, and you understand what Aspen Core is. 4 of the 7 top MCU selection criteria are related to ecosystem. And here we are talking about the ecosystem on the right side. 34% of the developers consider STM32 for their next MCU project, while other MCU providers are less than 15%. And this is not a marketing statement. This is just to inform you about the adoption of the STM32 that is happening in the world. When you are talking of STM32, you are talking of the ARM core. We are a company, we proudly associated with ARM way back in 2004-5. We were the first big semiconductor company to adopt Cortex-M in its form, and we are reaping the benefits, frankly. Thanks to ARM, we had our own core. We decided to go with them because we wanted to standardize. I said, we are having our own tools, but we are also having IR, we are also having Kyle, because once you know IR and Kyle, no matter if you work with STTI, NXP, Renesa, whoever, the tool remain the same. So the learning for the developer is less because the same tool means same IDE is working with one company, another company, third company, except that you change the part number that is relevant. Next, it's very, very important to work at the edge. Recall in the beginning, I said that there would be, let's say, proliferation of the edge-enabled or AI-enabled edge devices, which essentially are IoT devices at the end. And to have that AI at the edge, you need to do something on your microcontroller side also. One of the first things is also security and then the cloud connectivity. And you would see in the next slides how we are addressing that. Explosion of AI-enabled devices is really accelerating the inference shift. Inference, you understand, is the decision from the cloud to the tiny edge. So what happened in that first chart what I showed? You were having IoT devices sending all the raw data to the cloud. Decision was happening at the cloud. Inference was happening at the cloud. It's happening in most of the cases even now. But there is a shift from cloud to the tiny edge. What is tiny edge? It allows you to have certain capability at the edge itself. That means at the final node itself, that you don't need to send everything to understand what is happening in front of you. It could be maybe there is some face recognition. Face recognition is a little complex, but maybe you just need to detect few faces. That could happen at the edge also. And for that, we brought out something which is very, very tiny edge centric. That means we, out of those 1,000 parts, we are having some parts which are very, very good for the edge AI. Good point is that all the tools will work similarly. So inferring at the edge brings substantial benefits, as you can see, ultra low latency, because you don't need to send to the cloud. You can decide locally. You can implement the decisions very, very fast. You need less data transmission. That means you don't need very, very high bandwidths now, and then so on. I go a little fast because I want to not take more time than what you have. And these applications today can be done directly at the edge. So these kind of simple things, sound analysis, for example, if someone is honking as an example, this could also mean, okay, if someone is starting to dance, I don't know why, but okay, it could happen. Then making AI at the tiny edge a reality is what we are doing and how we are doing. Of course, we are having our own AI tools. Okay, you see, it's also important to share with you that what we know is important, because there could be many other stuff that we don't know. That more than 51,000 active projects were there on ST's AI tools by end of Q3 24. When is end of Q3 24? We are talking of September, October. So the data that is coming to you is brand new, something which is newer than new in few slides. And then we have this neural network accelerator for that, and that is what is helping us. And this goes into our brand new product, which is called STM32N6 or only N6. And this is the first MCU with neural networks. And by the way, for us also, it is one of the fastest products to beat 100 million in the STM32 history. Okay, this is important for me to share with you. One is where industry is moving. Second is how we are responding, and all of that together with the ecosystem. This is the development ecosystem to lower barriers to entry and faster project success. We have all of that. I don't know if some of you are part of this, but last year we had a contest in ST for STM32 models. If you remember that, this is the model that we were talking about. If I heard that there were some faculty joining from Tamil Nadu colleges also. We had some models who examples coming from Tamil Nadu colleges by the way to ST. So if some of them are there, maybe you can write in the chat that you had submitted one. But I just want to connect that this model zoo that you developed would go here. Of course, we have our own benchmarks and so on. More importantly, we have this ST Edge AI suite, which will give you the possibility to get started. These are the applications. I skipped this. This is not all. Something more interesting would be available very soon. So what we talked? I talked of TMOS sensor as a new product. I talked of N6 as a new microcontroller, saying that whatever is known as IDE for classical STM32 would be applicable to STM32 N6 as well. Now we enriched a little bit further, and that is in the connectivity domain. ST and Qualcomm recently signed an agreement, and as a result of that, we would have something which is first Wi-Fi 6 module series together with Qualcomm's SoC. This is not yet announced. You see, first products would be available to OEMs in Q1 2025. So something that would be available to you starting perhaps Q2 in 6 months from now is what is coming up. So I just wanted to give you the perspective. Rich portfolio, coming new devices for several applications. TMOS was just one example, but also big alliances to cover the whole spectrum of IoT, not only IoT. Something for the future. And in this case, it is coming from the universities, just as a note. We are talking of the technology. Remember, I said we are an IDM, integrated device manufacturer. We also have something which is FDSOI, fully depleted silicon on insulator. This is a new project that is happening between ST, Berkeley, and University of Lille. What we are doing through this is there is this FDSOI, there is IoT and wearables, and as I said before, it is more than more kind of integration. What we are trying to do with some of the universities is this. We call it human intranet. All of this in a technology. I can't speak more than this, but what you see over here is the name of the student or the professor or someone from ST who is working jointly on this project. Okay, so this is something new which is coming into the healthcare, wearable, everything that I said before. So it's networking on the body, but then the body would have some kind of access point if you want, which is connected to the internet. So it's again a IoT device in that sense. Jumping gears now. I have been requesting you to have focus more and more on the electronics, not only on the boards that you get from a company like us, but to nudge your students to make one by themselves. Because form factor boards or device prototypes in any case are available from a company like ST. What is missing is final product, and I call this as electronic system design. I had said that this slide would be used later. This is the time. And with that, I jump to the Sand to Silicon Electronic System by IESA, where I belong to as well. Your attention to understand it a little differently. It is a little bit outside the IoT context, but I want to focus on the system design part. For what concerns top level is what we call as the design. India is very good in design. Some people say 25%, some even claim 30% of the entire design, semiconductor design, SoC design of the world is happening from India, but mainly for, let's say, multinational companies like mine. Front-end manufacturing was absent. Maybe Tata's will come soon with the front end. Back end, there is a lot of discussion. There was Ruchi Semicon, I think 2-3 days ago. That is in your part of the world. So congratulations to them. If some of you are associated with them, congratulations to you also. There is a missing piece, and that is electronic system design and manufacturing. I make this big I. Big I is industrialization. So one is what I said, shrink the system to fit into the form factor. Second is industrialize it. That means it should be capable of being produced in mass and large numbers. That is industrialization. This aspect is what I have been highlighting to. I have been highlighting to every faculty member and also on the forums that I speak, that more than having a published paper, having a design done by a student is something that will put us in the category of the product nation, which we are not yet. And why it is important? Let's look at it. This is some IESA data. It says ESTM is the second largest importer after the oil. That is good. Just one data point. In let's look at one point. We are consuming about $300 billion of the electronic system design, $85 billion worth of semiconductors, out of which only 3 billion is purchased in India. So let's forget this purchasing part. Just look at this. ESDM is 300 billion and semiconductor is 85. Where is this more than 200 billion going? This really is the system design. When you have a very leading mobile phone which is manufacturing in Tamil Nadu, for example, they consume a semiconductor may be worth $100, but the final product is more than $1,000. It's coming because of the system design. That's why I was highlighting time and again. Please focus on system design by yourself and for the students. With that, I come to the last part, and that was to speak about the educational platforms. As ST, we have a list of courses which are available: IoT, machine learning, low-level firmware, robotic automation, TinyML, and so on. So if you go to this link, and this link should take me here. So if I go to, for example, let's say low-level programming with the drones. Here you see it takes you to a course by a professor, the University of Man. Okay. Let's go to the robotic automation with the drones. It takes us to Professor Ricardo, University of California, Santa Cruz. Next one. Let's go to motor control. It takes us to UCLA. All these courses have been designed. And if you look at, for example, accessing it, if you have to access it, it is available. So it is some company security, but anyway, you can see it. Here you can see what is the introduction. Okay. You can see the videos, you can see the resources, and more than anything else, you can use the resources by yourself. You can augment the resources. Same is true for this one also. Let's say robotics. You go to Access Now. You would find that there is this you see Santa Cruz robotic engineering program. There is a lab that is given, details are given, how to work on MATLAB is given, and so on. So all that physics, the mathematical modeling, whatever is relevant is given. That means you already have a base to start with. If, for example, you decide to say that you would like to, let's say, start working on, let me, okay, maybe robotics or maybe tiny ML and so on. All these courses are available, made some years ago, mainly by the professors in United States. You can be the next. If you have this appetite, please get in touch with me, with us, and we have the possibility of working together and helping you. Also, I showed this board earlier in the context that we have this sensor tile. And when you have this sensor tile board, this is the kind of packaging. It comes in the Nucleo X Nucleo format, but also it can act as a standalone node. And then all those examples that are relevant to sensor tile can run here, and it can be used to teach a system design at perhaps the graduate level, in my view. Then, of course, there are many ways that there is software development. You can do what you want, and then, of course, you can really make some end system because it is in the form factor. It's a RF board and FCC certified. And then, of course, there are other stuff on the sensor tile. There is a freshman curriculum. There is a capstone design, and then there is a curricula and content development. So these are some of the aspects that are kind of available to you to get started very soon if you think one of these is interesting to you. I want to go to the last part now, that if you decide to create an STM32 based IoT lab, first of all, I want to have a disclaimer. I'm not here to promote ST. I'm speaking to the faculty, but then I can use the resources that are easily available to me, and this is what is available to me. Of course, not to deny that anyway STM32 is the most loved microcontroller in the world today, most used. And then there is a reason behind. I showed you how we have positioned it as number one and what we are doing additionally to really stay at the top position also. So for example, any of these tools can be useful for you. You can start with STM Nucleo boards, discovery kits, evaluation. You can decide. All this information is anyway available. What is important is, and I want to highlight, is that there are further resources. So there are ST community pages. There are, for example, if I go to STM32 education again, here you would see that there is a huge information that is available. I want to highlight, other than everything else, just look at the MOOCs, which you understand many of you may have created. If you go here, you are able to really understand by yourself at your own pace the basics, MOOCs for STM32 tools, different STM32 lines, different applications, and then different ways of working. So this is such a powerful resource. So you can think of, let's say, robotics on one hand, and then these MOOCs on the other, and then you can use them as they are. You can ask the students to go through by themselves, but better you internalize for yourself and then start teaching what is relevant to you. So there is a huge work that is available to you without even creating an account, and that's important. Without even spending a single rupee, all this information is available to you, plus many more. There is GitHub, Wiki, etc. But, and for example, this webinars and okay, I should webinars and so on. These are, let's say, available. In fact, there was a STM32 stuff that happened just a few days ago. Yeah, this is STM32 Summit. So then, in fact, whatever I spoke to you, talking about N6 and so on, was actually available just here. I can share with you that what I said about N6 was exactly like this, was exactly this. And until some days ago, we were not allowed to speak it outside. Thankfully, our FDP is happening after 10th, 11th December. Until that time, it was not allowed to be spoken because there is a time that you speak to the word. So anyway, it was happening in good time in that sense. So these are the MOOCs I already described. Then you can go for the product selection for a lab. There is a details that you can go to www.st.com. There are possibilities you would find like this. I was saying that most of the boards could be available for, let's say, 10, 20, $50. And then there are distributors that you can connect. And of course, there is a whole ecosystem. With that, I want to really go to the last part, and that is my conclusion for today. I jumped from here. So what we described was ST microelectronics, megatrends, example IoT applications, wearables, smart lock, smart meter I did not cover, as I said, I left it. Then I described what is ecosystem today. In the end, we described about creating an IoT lab. Uh, Between, I was speaking about the partnership approach and how we are addressing the IoT movement by new products, new technologies, new partnerships. I spoke out of the context, but I felt it was important to share my view with you that to be a product nation, we need to start, and we need to start with you. When you understand the importance, I think students would understand the importance and country would benefit. Anyway, to summarize, key takeaways from my speech today are IoT applications will continue to augment our experiences, no doubt. An ecosystem of developer tools is available from the semiconductor suppliers today, and getting started is easy. Edge intelligence augments the IoT to the next level, and it will reduce the need to communicate raw data to the servers. We have seen it. And prototype to a saleable end product requires multidisciplinary approach, and collaboration with the adjacent industries and also competitors is paramount to achieve this. With this, I thank you for your attention. This is my mail ID that you can write to for any queries. And with that, I stop sharing and I will look at any questions in the chat if there are any. Is there any encryption decryption employed in the smart lock? Yes, we have a product. In fact, for that it is called ST Safe. So ST Safe was part of the base material.
Yeah, participant, if you have any question, please raise your hand.
Okay, where I am. I could see one question that I answered. So there was encryption, decryption employed, yes. Okay.
Anyone?
Okay, thank you. If these topics are new, that was my intention. And my intention was to really give you the perspective of how semiconductor companies are working, to tell you that building an IoT system is not tough anymore.
Sir is looking at the chat.
And okay, how to access the educational tools? I gave you the information, but then let me just write in the chat again. Yeah, I think this should be good. If you see the chat, this is our link to the educational platforms. Keep in mind that from there you already have large number of labs, large number of classes, large number of PPTs, but also you can go through the MOOCs. MOOCs is actually very, very important aspect of the entire stuff, frankly. I will try to give you the link of the MOOCs also, and I am putting in the chat the MOOCs part. I can't see any more questions. I mean, I see all the questions,
Yes, sir,
but I don't see there if there are any other questions. So please share all the slides to mail. I'm not sure if I can do that, but okay, I will try to do what I can do. Because as I said that I wanted to make sure that you understand. So I used some data that is available to me as a privilege because I work in ST, but then it may not be allowed. For example, what is coming from YOL, etc., etc. You have to take permissions because Several reports are costing several thousand rupees. I shared them, but in good faith. So if I have to share my slides, I have to cut many of those for sure. You can imagine.
So I think we should conclude if it is no question.
Okay, so thank you from my side. Thank you for being very good. I can only say so. I wish that you were interrupting me more, but in the online, I think this is best we can do.
Okay, thank you very much, Dr. Manoj Kumar. It was a very, very interesting and very informative session. You have also shared the just a minute, sir. Okay. Uh, yeah. So we extend our thanks to Dr. Manoj Kumar, and I also I'm thankful to the audience or participants also to be listening for this. About 134, 136 participants are already there. So I believe that you must have got lots of knowledge out of this, and you will be able to take forward this knowledge further in your field. I believe most of us are faculty, so we are very much thankful to Dr. Manoj Kumar. Thank you very much, sir, and hope we will get more and more interaction in the future. Thank you.
Thank you.
Thank you.
Thank you. Thank you.